Hello guys, this in this video I'll start the chapter 2, that is the stellar magnitude. Okay, so that will be stellar and magnitude. So in this topic I'll talk about the apparent and the absolute magnitude. I'll talk about what happens when there is any obstacle in between the observer and the star. Okay, so what will be the expression? Then I'll talk about the numerical part. Okay, so that is the plan. So let me go back to the apparent magnitude. What is the apparent magnitude? Consider this is the earth. Okay, so I am observing the distance star. Okay, so apparent magnitude is the distance, is the magnitude of or the luminosity that I am receiving. Okay, मैले जसरी त्यो स्टारलाई देखिरहेको छु त्यसबाट मैले जुन अब जतिको लाइट पाइरहेको छु अथवा जति चम्किलो त्यो देखिरहेको छ, that is the apparent magnitude. It doesn't depend upon the distance, it does not depend upon any other factor, since I am observing irrespective of the distance that it is far or near to me. This is just a classification, that is the apparent magnitude. The difference between the apparent magnitude and the absolute magnitude is that the apparent magnitude does not like it does not take into account of the distance, so we cannot tell whether the two between two star which is more brighter, because if one star is much more brighter but at a very large distance. For example, if this is a star, okay, so it and another star is here. Okay, so it is much more brighter. So if this is b, this is b, and if b is greater than b, okay, but still if I observe from the earth, I will find this star as more brighter. Okay, but it is not the case. Okay, so this is the apparent magnitude. But if I now take the distance into account, or my distance login भने, then I'll know that this star is more brighter. That is the absolute magnitude. Okay, so that is the difference between the apparent magnitude and the absolute magnitude. So from the experiment it was found that apparent magnitude is, if there are two star, then I can write the apparent magnitude as k log, and this is the brightness, that is b1 by b2. Okay, so later on what it was found that if m1 minus m2, that the scientist called Poxon, okay, he found that if m1 minus m2 is 5, then b1 by b2 will be 1 by 100. So if I replace this value in this equation, I'll find that k value minus 2.5. So our whole equation will be m1 minus m2 minus 2.5, and then log, and then b1 by b2. This is the expression of the apparent magnitude. Okay, so now if I want to calculate the exact amount, if I want to get the pure, okay, original, okay, the authentic data, okay, so that I can relate between those two star, I will take into the distance. Okay, so what the fundamental distance, or the very standard distance is 10 pc. Okay, so from the inverse square law, what does it tell? Intensity is directly proportional to the distance square, so which is directly proportional to the brightness. So if consider that this is the star that has the apparent magnitude m1, and if I consider any star that is in 10 pc distance from me, that is the, and if it has a absolute magnitude of m, so that will be b1 by b2 is equal to, since it is inversely proportional to, so that will be 10 by r whole square. Okay, so now my equation will be m, let us not write m, I'll just write capital M. Okay, so m minus absolute magnitude minus 2.5 log, that was b1 by b2. Now I'll write 10 by r whole square. Okay, so if I solve this, I will get 5 log logarithm r minus 5. So this is the equation of the absolute magnitude. Okay, this is the equation of the absolute magnitude. Now what I will do is that so square will be go here, it will multiply here, it will give us 5. Okay, so that 5 log 10 minus this is how I can get the value. So now if what if there is an the dust in the way, like I cannot directly observe. Okay, so there are always gas or dust in between, so this is where I am observing. This is the star, but in between this path there is a lot of gas and dust, which obviously the some part of the flux is lost in between the path. So to include that effect, now I will consider a luminosity flux as decreased by d L is equal to minus alpha L d R. Okay, this alpha is called the optical opacity. Now I'll write it as a d, that I'll introduce a new symbol, that is dt is equal to alpha and then L. Okay, that is the minus alpha L. Now I can rewrite this equation as dl is equal to, okay, that will be d d d r. Okay, so suppose this is where I am observing. Okay, so if I want to draw a diagram, okay, so I'm diagram but म बुझाउने कोसिस गर्दैछु, so it will be more clear to you guys. Okay, so for example, this is where the luminosity is L, and this is where the luminosity is L plus dl. So what will be the change in luminosity in between these two, or the loss of luminosity, that is dl. Okay, dl is directly proportional to the what I'm writing, that is I'm writing minus alpha ldr. Okay, so the alpha is called the opacity factor. Now I introduce the t factor, that is called the optical thickness. Okay, so optical thickness, which is indeed is equal to the opacity times the luminosity. Okay, no, that is not minus, that is simply, that is t is equal to alpha L. If I take the derivative, it will be alpha dl. Now this value will be dl is equal to it will be equal to minus L dt. Okay, so no, sorry, my mistake. So that will be dl is equal to, the loss in luminosity is equal to minus alpha L dr, and the optical thickness will is equal to the alpha r. If I take the derivative, it will be alpha dr. Now the equation 1 can be written as dl is equal to minus L d, and that is the optical thickness. Okay, so if I integrate it from the L naught to L, and this from 0 to t, with this is not it, this is the optical thickness, it will indeed give me the value of what I can get. I will get L is equal to L naught, and then log cosine uta gaera minus, it will be t. Okay, so this is important later on, guys. So let me call this equation 2. ओके, सो यो एल चाहिँ यता आएको चाहिँ, यो चाहिँ कसरी गरेको भन्दाखेरि, यो जुन एल जुन बच्यो नि, सो द्याट डिएल बाई एल भयो, एन्ड देन एल नट बाई एल, यता के बच्यो, यता त के बच्यो, यता के बच्यो भनेपछि डिटी बच्यो होइन, 0, द्याट इज अप्टिकल थिकनेस, यति मात्र बचेको त नि। यहाँबाट के आउँछ, लगारिदम आउँछ, जुन लग उता गयो भने ई टु द पावर माइनस टी हुन्छ, अनि तलको एल नट चाहिँ माथि गएर यो फङ्सनमा चेन्ज हुने हुन्छ। ओके, now I define the luminosity as L is equal to omega r square and f r, that is the flux density. Now L naught will be equal to the omega r square f naught. Okay, now if I substitute L को ठाउँमा मैले त्यो र L naught को ठाउँमा मैले त्यो राखेँ भने, I will obviously get the value f r is equal to capital R square by R square. Okay, then this will be f naught, and this will be e to the power minus t. So this is the equation 3. Now go back to the absolute magnitude equation, that was m minus m is equal to 5 log r minus 5. It can be written as 5 log r minus 5 log 10. So यसलाई मैले कसरी लेख्न मिल्छ r by 10. ओके यसरी लेख्न मिल्छ हैन. नाउ फ्रम द इन्भर्स स्क्वायर ल fr लेखेँ मैले f not लेखेँ. ओके f10 भनौँ न f10 लेखेँ. So this will be 10, this will be r, that will give me the square root. Okay, so instead of from our previous equation of the apparent magnitude, I have the formula that is indeed b1 by b2, which is the brightness. Instead of writing that brightness, I can write it as a fr by f10, okay, which is the same thing. So now I'll just use some algebra. This is fr. Now I'll write f naught, then f naught, and then f10. अब fr by f naught को भ्यालु त मलाई थाहा छ हैन, यो काम मैले क्याल्कुलेट गरेको छु नि. fr यो f यता गयो भने fr by f naught हुन्छ. So I can write it as a minus 2.5 log, that will give me r square by r square e to the power minus t. अब f naught by f10 मैले कति लेखेको थिएँ, that is given as, okay, so f naught by f10 will be 10 divided by r. Okay, so that will be square. अब यो r square र यो r square त काटिने भयो हैन. त्यसपछि हामीसँग के बाँकी रह्यो त, त्यसपछि यो लगारिदमले यदि मैले यसलाई खोलेँ भने फाइनली आई विल गेट द एक्सप्रेसन लाइक, कस्तो एक्सप्रेसन मैले पाउँछु भनेपछि m minus m is equal to 5 log r minus 5 plus 2.5 log e, okay, then t. अब यो t को ठाउँमा मैले के लेख्न मिल्छ, I can write it as alpha r. So this is the extension value. Okay, त्यो त already यो absolute magnitude को value भइहाल्यो. So what we can conclude, हामीले के conclusion निकाल्न सक्छौं, the apparent magnitude was given by m1 minus m2 minus 2.5 log and then b1 by b2. Okay, so if I consider at is a distance, यदि मैले distance consider गरेँ भने then I'll get the absolute magnitude, which is m minus n, which is the same expression, that will be 5 log r minus 5. Now if I consider the dust particle, or that is called the extension, okay, those dust particle are called the extension. If I consider this, I'll get the expression like same expression, but I'll get the additional term that is called a. Okay, so that a is called 2.5 log e and then optical thickness. So this is indeed the chapter 2. Okay, so guys, this is what everything we learned so far. So in this next topic I will discuss the numerical from this chapter. Okay, so यसमा नबुझेको के कुराहरु छ भने प्लिज कमेन्ट सेक्सनमा लेखिदिनु होला. I'll be more happy to assist you guys. Okay, so thank you for your time.